Hey Geometry! Our learning target for today's notes is that I can prove that two triangles are congruent using theorems and postulates. So in our last notes, when we were proving that triangles were congruent, we needed to show that all three pairs of sides were congruent and all three pairs of angles. So it ends up being kind of a long proof. Fortunately, we have some shortcuts so that we don't need to show that every single side and every single angle in your two triangles are congruent. So we're going to go through the shortcuts together, and then we'll look at a few examples of how to decide which postulate or theorem applies to the problem that we're doing. So our first congruence postulate is the side-side-side congruence postulate, and this one's usually abbreviated as SSS. Side-side-side congruence says if three sides of one triangle are congruent to the corresponding sides of another triangle, then those triangles are congruent. This one makes a lot of sense to me. If we have one triangle with side lengths of 3, 4, and 5, and I have another triangle with side lengths of 3, 4, and 5, those triangles are going to be the same. Our next congruence postulate is the side-angle-side congruence postulate. This one's abbreviated as SAS. Side-angle-side says if two sides and their included angle in one triangle are congruent to the corresponding sides and included angle of another triangle, then those triangles are congruent. So in here, it talks about an included angle. So what that means, if we look at our diagram, these are our two pairs of congruent sides. And the angle pair that's marked as being congruent is in between those two congruent sides. So when they say an angle is included, it means it touches both of the sides that we're talking about. Our next postulate, this one's a theorem. Our next theorem is the Angle-Side-Angle Theorem. This one's abbreviated ASA. The Angle-Side-Angle Theorem says if two angles and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then those triangles are congruent. So we have some included things popping up again here. This time we have an included side. So on the diagram, we can see that we have one pair of congruent angles and a second pair of congruent angles. And this side that's marked as being congruent touches both of those angles. So that's what we mean by that side being included. It's in between the two angles. Our next congruence theorem is angle-angle-side. This one is AAS. In angle-angle-side, we have two angles and a non-included side of one triangle are congruent to two angles and the non-included side of another triangle. So we can see our two pairs of angles here. It's the same pairs we had in the example before, but now we have a non-included side. So what that means is this side that's marked as being congruent only touches one of those angles. It's not in between both of them. Our last congruence theorem is a special one. It's hypotenuse-leg. The hypotenuse-leg congruence theorem says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then those triangles are congruent. So the important thing here is that we have to be talking about a right triangle. Right triangles are the only triangles that have a hypotenuse. If you remember, think back to when we were going over all these definitions in I think it was in unit 2. The hypotenuse is the side across from the right angle. So in these triangles, we know that our hypotenuses are congruent, and legs are just any other side in the triangle. So we also have a pair of legs that are congruent. So in our first 4 congruence postulates and theorems, we need 3 pieces of information. We need 3 pairs of congruent corresponding parts. For hypotenuse leg, we only need 2 pieces of information. We only need corresponding congruent hypotenuses and 1 pair of corresponding congruent legs. We also need to know the triangle is a right triangle, though. So one of the biggest places where students make mistakes and where the most misconceptions happen is the difference between things that are included and not included. So if we're talking about included sides and angles, your included side will touch both of the angles that are marked. So I'm going to draw in a triangle here. I'm going to mark 2 of my angles. My included side is going to be the side that touches both of those angles. So that would be this side right here. So if this was triangle ABC, my side BC is included between angle B and angle C. If we're looking at an included angle, I'll draw a new triangle for this one. An included angle is going to touch both of these sides marked. So if I have triangle DEF here, I'm looking for my included angle between those 2 sides. Well, angle E is my included angle. So I could say angle E is included between sides DE and sides EF. So what you'll notice here is that if we're looking for the side included between angle B and angle C, well, that's side BC. It's the side that's marked by those 2 angles. If we're looking for the included angle between sides DE and EF, well, what these 2 sides have in common is angle E. If we're looking at things that are not included, a non-included side will only touch one of the marked angles. So if I draw that same triangle that we had in the other one, where I have angle B and angle C as my marked angles, a non-included side would be like side AC. Side AC does not touch both of my marked angles, it only touches one of them. And if we're looking at a non-included angle, so if I put triangle DEF back up here and remark those sides, a non-included angle would be like angle F. Angle F is only touching one of my marked sides, not both of them. So on the back, we are going to talk about these 3 problems on top. We are going to look at our diagrams and determine if we have enough information to prove our triangles are congruent. So if we look at what we've got going on here, we have 1 pair of congruent angles. We know that angle A is congruent to angle D. We've got another pair of congruent angles. We know angle B is congruent to angle F. And we have 1 pair of congruent sides marked here. That side AC is congruent to side DE. So looking at the information that I was given, we have 2 pairs of congruent angles and 1 pair of congruent sides. So that leaves me with the options of this is either ASA or AAS. The difference is that an angle-side-angle, the side is included between the angles, and an angle-angle-side, the side is not included in between the angles. So if I look at the side that's marked as being congruent, these sides are not included. So I would say that yes, these triangles are congruent, and the theorem that I would use is angle-angle-side. And now when I write my congruent statements, for my first triangle, if I call it triangle ABC, I need to match up the corresponding angles for my second side of my statement. So angle A matches up with D, B matches up with F, and C matches up with E. Okay, next one. Let's see what we've got on our diagrams here. Okay, we've got 1 pair of congruent angles. Angle L is congruent to angle K. We've got another pair of congruent angles. Angle A is congruent to angle J. And we have a pair of congruent sides. Side AL is congruent to side KD. So we've got 2 pairs of angles and 1 pair of sides again. So we're looking at either, is this angle-angle-side, or is it angle-side-angle? So when I look to see if my side is not included or included, in my first triangle, side AL is included between those 2 angles. In my second triangle, side KD is not included between my 2 angles. So what that tells me is that these triangles are not congruent because their corresponding sides are not congruent. In order for the sides to be corresponding, I would need to know that AL and JK are congruent, because those are the angles that are corresponding. So if we need to include an explanation here, well, this isn't either of these. This is not congruent because our corresponding sides are not congruent. Okay, and last example we're going to do together. We don't have a lot of information here. Here's what we've got. We have 1 pair of congruent sides marked. I know AC is congruent to CE. And that's all that's marked on my diagram. But I do have these guys on here. Those arrows tell me that those lines are parallel. If we think back to what we remember about parallel lines, I am going to highlight these and draw them out a little bit longer so we can see them. Okay, if these are my parallel lines, and this is my transversal. Oh, let me draw that better. Here's my transversal. Okay. When I have 2 parallel lines cut by a transversal, I get lots of angle pairs that are congruent. In this one, I can see that angle A and angle E are congruent to each other. Those are alternate interior angles. So that was useful, my parallel sides. That gave me another pair of angles. Well, actually it gave me my first pair of angles. So now if I look at my diagram, I have one pair of congruent sides, one pair of congruent angles. I need more information to show that these are congruent. And what I have here is a pair of vertical angles. So at point C, I have angle ACB on the left that's congruent to angle DCE on the right. So now we've got two pairs of congruent angles and two pairs of congruent sides. So we are trying to decide, is this angle, angle, side, or angle, side, angle? Well, if we look at our side that's marked, that side is included between those two angles. When I check in my other triangle, the side that's marked is included between those two angles. So this time, we've got angle, side, angle. Yes, those triangles are congruent. When I write my congruent statement, if I write the first one as A, B, C, angle A corresponds to angle E, angle B corresponds to angle D, and angle C corresponds to angle C. Try the try-it problems underneath. The answer key for these will be posted under our completed notes section on Google Classroom.